Hi everyone, in this week's discussion we will be talking about differential equations. So to get started you need to use the letters in your first and last name and the little numbers here to figure out which function you're working with. So as an example, my name is Kathy Bliss and my first name begins with a C. So that means I'm going to be looking at the value of 1. And that's for the value of a. So for me, a equals 1. And that a equals 1, if I read through here, that tells me that I'm going to be looking at the first function here. So I know I'm looking at something like x plus 1 over b times y. Now to figure out what my b value is, the directions say to use the first letter of my last name. And my last name is Bliss, so that's going to also put me up here with a b value of 1. So that wasn't very exciting, but it is what it is. So my function is going to look like x plus 1 over 1y. All right, so we need to go over to Desmos and create a plot. Then I'll solve the differential equation, and then we'll go back to Desmos. So if we go over to Desmos here, there's a lot of information, and you don't need to go through all the nitty-gritty details here. But what you do need to do is edit line 2. So right here, this is where I've edited my function. As you can see, I typed in x plus 1. And I'm going to go down a little bit here, and I'm on line 13 and 14. I'm just going to turn off some things there so I don't have any curves. I just want to look at the slope field. And what this is, it means I'm looking at a bunch of slopes. I'm looking at a field of slopes. I've got a slope field. So I had a differential equation. There's going to be a lot of solutions for that differential equation. And really what that differential equation gives me is gives me information about the slope. So given a value for x and a value for y, I know what the slope is. So for example, when x is a 0, so I'm over 0, x is 0, and y is 1, so over 0 up 1, that tells me that my slope is going to be 1. So whatever curve is the solution, it's going to be driving through this point over 0 up 1 with kind of a 45-degree angle. And if I went, way up here, and this is x equals 2, y equals 4, and I plugged those x and y values in here, x equals 2, so I'm going to have 3 over 4 in the numerator, I'm going to have a slope of 3, 4. So it's a little bit not as steep. My curve is not as steep up here. So what that differential equation is giving you information about the slope at all these different points. And that's really all a slope field is. Now, suppose I want to actually solve my differential equation. Well, this is a separable differential equation. And what I mean by that is I can separate the x's and the y's. I want to get all the y's on one side, all the x's on the other side. So let's do that. Let's separate our variables here. So I'm going to multiply both sides of the equation by y. And I'm also going to move over my dx. So what I end up obtaining on the left is y dy. And on the right-hand side, I have this x plus 1 that was sitting there. The y's canceled out, and I have dx. So I've separated the variables. Once I've separated the variables, I can integrate both sides. Notice that on the left-hand side, I'm integrating with respect to the variable y. So the integral of y dy, well, that's just going to be 1/2 y squared plus some constant. And I'll call that constant, C1 or something like that. On the right-hand side, my variable of integration is x. So the integral of x plus 1 dx would be 1/2 x squared plus x plus some constant of integration. I'll call it C2. Now, my goal here is solve for y. So we want to solve for y. So I'm really interested in getting y all by itself and everybody else on the other side. So one easy thing to clean up here would be those constants of integration. So let's move those over. On the left, I still have my 1/2 y squared. On the right, I've got 1/2 x squared plus x plus C2 minus C1. I just put that in some parentheses there. Now again, I'm still after y, so let's peel off this 1/2 coefficient out in front. To undo the 1/2, I'm going to multiply both sides by 2. So goodbye, goodbye. And if I do that on the left-hand side, remember, I've got to multiply everybody by 2. So I've got to distribute that 2 over all those terms. On the left, I have y squared. And on the right, 2 times 1/2, that just gives me 1. So I've got an x squared. I've got a plus 2x. And I've got a plus 2c2 minus c1. And you know, this is just getting too cumbersome for me to deal with. So let's call that k. So let's let k equal 2 times c2 minus c1, and that'll just clean everything up quite a bit. So we'll just call that piece k. All right, where are we so far? On the left-hand side, I've got y squared equals, right-hand side, x squared plus 2x plus k. Solving for y, I need to take the square root, and I need both the positive and the negative square root. So I've got y equals plus or minus square root x squared plus 2x plus k. And that's my solution to the differential equation. So if we go back to Desmos, I can put in the positive square root, and then after that I just hit enter, and that gave me a new line. I typed in the negative square root, and so we have those showing up here on the graph, which is quite nice. Just recenter that. Now, what's even more fun, let me just see if I can scroll down a little bit here. We can adjust that k, that constant, and notice that, you know, if k were 1 or k were 1.6 or whatever it is, that changes the particular solution. So these are my general solutions, and then depending on which value of k I've got all these different particular solutions. And the way we come up with a particular solution is, of course, we feed in some initial conditions. Now, I won't get into the initial conditions right now. I'll save that for our discussion as we get rolling along with this topic, but hopefully this gives you a good idea of how to get started with this discussion. And if you have any questions at all, please don't be shy. Reach out to me early and often with questions.